Hello everyone, this is Uday, and today we're going to talk about a traditional watermill in Nepal. Watermill, or Pani Ghatta in Nepali, are in operation till these days, mainly in the hilly regions of Nepal. There is no exact evidence that when it was introduced in Nepal, but many historians believe that it's been in use before 100 BC. About 25,000 of watermills are operating throughout the remote Nepal, which produces power output of about 200 to 500 watts. These are not limited to the Nepali Himalayas, but can be found throughout India, Pakistan, China, and even some of the parts of Turkey. There are an estimated 200,000 traditional watermills in India alone. The wooden turbines are fashioned by local carpenters, which drive the grinding stone and are used to grind corn, wheat, and other grains for the local agricultural community. Some of the main parts of the whole systems are a chute to constrict the water flow, a turbine wheel, a vertical shaft, and grinding stones. The operation of the system is very simple. It operates on the very basic principles of hydraulics. Water is diverted from a stream, a river, and flows down a chute towards the Garter's turbine. The vertical shaft of the turbine runs off through the floor of the Gata house and turns the top stone of a pair of grinding stones. Grain is stored above the stone in a suspended woven basket. It slowly falls out through a feeder mechanism through the bottom of the basket. The top stone has a hole carved in its center all the way through it. Grain from the feeder mechanism falls down through this hole and is then ground between the pair of stones. The grinding stones are always inset slightly below the floor of kata house in a square depression. Typically, the top stone is little above the surface, but the bottom is well below. This square depression, well defined by four wooden boards, keep the floor from splitting out onto the floor. Water is typically diverted through a long 200 20 to 200 meters tunnel nearly the chute. There is an alternative path for the water to flow when the gata is not in operation. On the top of the chute, there is a gate that operates water flow, prevents surface debris from entering the and serves as water flow protection. The chute is generally made of hollow tree trunk and is placed at an angle of 40 to 50 degrees and has a 3 to 7 meter height with its vertical drop. Here, height means a specific measurement of water pressure or total energy per unit weight above a datum. It is usually measured as a water surface elevation, expressed in units of length, but represents the energy at the bottom. The water flows down the chute and hits the angled wooden planks that are the blades of the turbine. The main shaft of the turbine is a large piece of wood. The wooden plank blades taper down to 6 by 6 centimeter pegs. A peg is a short pin or bolt, typically tapered at one end, and is used for securing something in place. These pegs are pounded into slots carved into the shaft. The slots are slightly angled relative to the vertical axis of the shaft, and thus the plank blades are angled as well. A long metal rod, something like a very large nail, is hammered into the top of the wooden shaft. This extends the shaft from below the gutter house up to the floor through a hole in the bottom grinding stone. Small slivers of bamboo or other light wood surround it. These slivers act as a collar for the extended turbine. The top of the turbine shaft comes to a square post, a metal key, a flat rectangular piece of metal, is manufactured to have a square hole in its center that exactly fits about the post. The top grinding stone has a rectangular caved into it. The key fits into this inside, and this is how the shaft is ultimately connected to the top grinding stone. A second metal rod is also hammered into the bottom of the wood turbine shaft. This rod comes down to a point, and it is upon this point that turbine rotates. Now let's talk about the materials that are used to construct this mechanism. Gutters are made from local materials. The size of the plant can vary depending on the location. The grinding stones can come in different sizes, ranging the diameters from 24 to 34 inches, and the thickness can range from 3 to 10 inches. Most of the items used in it are hand carved. Hence, the plank blades of the turbine aren't really rectangular. The hole through the center of the top grinding stone does not stay on axis, and the top grinding stone is not centered on the top of the turbine shaft, and thus wobbles back and forth as it rotates, which is not beneficiary for a turbine for its efficiency. Now, let's move towards some technical features of this mechanism. The length can vary from 20 to 200 meters. Water discharge also does vary from 40 to 100 pounds per second. Normally, the speed of the runner is 120 to 160 rotations per minute. The power output varies from place to place depending upon the hydraulic head available and also from season to season as well. Normally, the flow rate of water varies from 40 to 100 liters per second. Their efficiency is less than 25%, and it can grind items about 10 to 20 kg per hour. If we talk about the efficiency of the system, it is very low in comparison with other sophisticated devices. And here are some of my suggestions that can be implemented to improve the efficiency of the system. We can use standard design to manufacture the items by maintaining uniformity in the blade angle, and the holes in the hubs must be concentric. And we should use standard weight of the runner. Maintaining proper impact angle with the water jet, since the hydraulic energy gets converted into mechanical energy because of the direct impact, it would be better if we design it in the bucket shape with the horizontal axis. There are lots of frictional losses between the shaft joints, which can be eliminated by proper lubrication. This technology is environment friendly, economically cheap, and suitable for Nepali terrain. It should be improved in efficiency and promoted throughout the country. Some of the water mills in Nepal have been upgraded by replacing wooden parts with better designed metal ones by the Center for Rural Technology, CRT, Nepal.